All right, in 6.1 part 2, we are going to take a look at a few specific strategies for simplifying trig expressions. Okay, now I'm not going to tell you what strategies to use on homework problems. Okay, these are just ones that you can try. And I should also emphasize that on a lot of these, there's more than one way to do the problem. Okay, so the important thing is just to start trying something. Okay, so we're going to go through a few specific strategies, and we're also going to use these same identities that we used in part one. Okay, our reciprocal identities, our quotient identities, and our Pythagorean identities. These are going to be the main ones that we're going to use. So I would recommend getting out your part one note sheet so you have these handy. Okay, now when we do get to a quiz or a test over these, I will ask that you have all of these memorized, okay? But hopefully that memorization will come just with working with them so much here, okay? So for now, I would recommend having this sheet out, all right? So the first strategy that we're going to look at is to factor, okay? So in this example here, we can factor by taking out a common factor, and I can factor a cotangent squared out of both of these. If I do that, I'll be left with 1 minus cosine squared. Now, 1 minus cosine squared, that is a manipulation of one of our Pythagorean identities, right? If I were to subtract cosine squared over, I would have 1 minus cosine squared is equal to sine squared. So I can just make this cotangent squared times sine squared. Well, now I know that cotangent squared is equal to cosine squared over sine squared. So now, if I've got a sine squared in the numerator and a sine squared in the denominator, those will cancel, and I am just left with cosine squared. Okay, so this whole mess at the beginning is just equal to cosine squared. All right. The next strategy that we want to take a look at is to multiply by a conjugate. Okay? Whenever we have a denominator like this, okay, where it's a trig function plus or minus 1 usually, if I multiply by the conjugate, remember a conjugate is just putting the opposite sign in the middle. So the conjugate of secant of beta minus 1 would be secant of beta plus 1. So if I multiply the top and the bottom by the secant of beta plus 1, okay, I'll show you what happens and I'll explain why this is a useful strategy. Okay, so in the numerator, I'm actually just going to leave this as tangent squared of beta times secant of beta plus 1. I'm not going to multiply this one out, but I will multiply out the denominator here. So secant times secant would be secant squared. Secant times negative 1 would be negative secant. Then 1 times secant would be positive secant. And then 1 times negative 1 would be negative 1. That's all in the denominator. And then we still have this minus 1 out here. Now, remember, we're allowed to do this because this is just multiplying by 1. So this doesn't change the value. Now, in the denominator, I've got a negative secant plus secant. Those will cancel. And I'll have tangent squared of beta times secant of beta plus 1 over secant squared of beta minus 1, and then minus 1 out here. Right now, the reason that we multiply by a conjugate, right, is we end up creating something like this. And no matter what trig function we're using, this is almost always some kind of manipulation of one of the Pythagorean identities. Okay? So if I look, secant squared minus 1, well, here, if I were to just subtract 1 over, I would have secant squared minus 1 equals tangent squared. So I can replace my denominator here with tangent squared. Now, these tangent squareds cancel, and I am just left with secant of beta plus 1 minus 1. Obviously, plus 1 minus 1 cancels out, and I am just left with secant of beta. So this whole thing, this ugly thing at the beginning, just ends up being equal to secant of beta. Okay, now obviously these ones are a little bit more involved than the ones that we did in part 1. Okay, but the important thing is just to start trying something. You may get to a dead end. Okay, then try a different strategy. The next strategy that we want to take a look at is whenever we're adding fractions together, right? We may have to get common denominators. So let's take a look at this example. Cosine over 1 plus sine plus cosine over 1 minus sine. So to add these together, we need to get common denominators. So I would need to multiply this by 1 minus sine of alpha. And then I'll multiply this fraction by 1 plus sine of alpha. All right, so in my numerator, I am actually going to multiply this out. Okay, so I'm going to get cosine of alpha minus sine of alpha times cosine of alpha over, okay, now if I multiply this denominator out, I'm going to end up with 1 plus sine minus sine. So I know those are going to cancel out, and then I'll be left with negative sine times positive sine, so minus sine squared of alpha. Then over here, I'll have plus cosine of alpha, and then cosine times sine of alpha, or sine of alpha times cosine of alpha, all over that same denominator, 1 minus sine squared. So now, whenever we're adding fractions, we just add the numerators together. What ends up happening here, right, I've got negative sine of alpha cosine of alpha plus positive sine of alpha cosine of alpha. Those end up canceling out, and in the numerator, we're just left with 2 cosine of alpha. Right? Cosine plus cosine would be 2 cosine. Now my denominator, I'll go ahead and write it as 1 minus sine squared, but this is a manipulation of one of my Pythagorean identities. If I were to just, which one was it? 1 minus sine squared. So if I were to just subtract sine squared over, I would have cosine squared equals 1 minus sine squared. So here I can change the denominator to cosine squared. So we'll have 2 cosine of alpha over cosine squared of alpha. Now, I can cancel out one of the sets of cosine, right? So this denominator, if it's cosine squared, it's really cosine times cosine. So if I cancel one of those out, I'm just left with 2 over cosine. And then finally, I know that cosine is the reciprocal of secant. So I can say that this is just equal to 2 times the secant of alpha. Right? This whole thing at the beginning just simplifies to 2 times the secant of alpha. Our next strategy is going to be to split up a fraction into 2 separate fractions. Now, we can only do this if the denominator is a single, well, I shouldn't say that. We only really want to use this if the denominator is a single term, all right? We can, if there's addition or subtraction, we could split it up, but generally we only want to use this strategy if the denominator is a single term. So here, right, what we can write this as is cosecant of x over cosecant of x minus sine of x over cosecant of x, right? That's just basic arithmetic, right? That we can split up a fraction like that. We can split it up here and here. Obviously, cosecant over cosecant is just equal to 1. Anything over itself is 1. Now I've got sine over cosecant. Well, I know that cosecant is the reciprocal of sine. So this was really sine times sine, right? If I've got cosecant in the denominator, that would be the same as sine in the numerator. So this would really be sine squared of x, right? I guess we can write this out and say this would be the same as sine of x times 1 over sine. Right? That's how we're saying that cosecant comes up here as just sine. Well, and then 1 minus sine squared is just a manipulation of a Pythagorean identity. If I subtract sine squared over, I'll have cosine squared equals 1 minus sine squared. So this is just cosine squared. All right. Our last strategy that we're going to look at is just change everything to sine and cosine. Okay? We can write all 6 trig functions in terms of sine and cosine because we know that tangent is sine over cosine, cotangent is cosine over sine, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Okay? So all 6 trig functions can be written just in terms of sine and cosine. Now this is actually probably one of the more popular strategies, okay? Just to rewrite everything in terms of sine and cosine and see what you can do from there. Okay, so let's go ahead and do that. I can rewrite the inside here and say this is sine times, oops, let's change that back. Tangent, we just said, was sine over cosine. And then cotangent is cosine over sine. Now, in here, we have fractions. Right? Let's try to add these together. Well, to do that, we need common denominators, like we talked about a couple strategies ago. So I'm going to need to multiply this fraction by sine over sine. Right? So we squeeze that in there, sine over sine. And then I'll need to multiply this one by the other denominator, cosine. So cosine over cosine. Now, when I do that, this sine will still be out here, times, so I'll have sine squared over sine times cosine. Plus cosine squared over sine times cosine. So now, again, we can just add straight across. So I'll write it all out. So we'll have sine squared plus cosine squared over sine times cosine. I forgot my square there. There we go. Now, sine squared plus cosine squared is a Pythagorean identity. Sine squared plus cosine squared is just equal to 1. So this whole numerator just becomes 1. And I've got sine of theta times 1 over sine times cosine. Now, if I multiply, right, again, if we're multiplying, this would just be sine over 1. Multiply that in, I'll have sine of theta over sine of theta times cosine of theta. The sines would cancel out, and I would just then have 1 over cosine. And we know 1 over cosine is just equal to secant. Okay, so we had to use 2 strategies here, really. First, we just changed everything to sine and cosine, and then we got common denominators to add these fractions together to see what we could do from there. Okay, I do want to just do one final example here that does combine a few more of these strategies together. Okay, so in this example, again. We want to start by multiplying by a conjugate, right? That's really the only thing I could see here. I mean, we could change tangent to sine over cosine. That actually would be another decent strategy that we could employ here, and then add those together. But I'm going to approach it differently. Now, like I said, there usually is more than one way to go about these problems, right? So changing this to sine over cosine would probably be a decent first step. Get common denominators, add these together, see what you can do. I'm going to approach it a little bit differently, though. I'm going to multiply by the conjugate. So I'm going to multiply top and bottom by 1 minus sine of x and 1 minus sine of x. So this tangent will stay out here, and we'll have plus. Now, I'm not going to multiply the cosine through. I'm going to have cosine of x times 1 minus sine of x. Now, you're probably going to ask, well, how do I know when to multiply something through and when not to multiply something through? You don't, okay? You just have to try it one way or the other. Right? In this section, there's going to be a lot of guessing and checking. You're going to do something wrong, right? You're not going to use the correct strategy at first, and that's okay, okay? The important thing is just to try something and see where it gets you, okay? You may have to start the entire problem over, and that's perfectly fine, right? Just try a strategy, see where it gets you. If it doesn't get you anywhere, try something else, all right? So here, I'm not going to multiply the cosine through. In the denominator, I will end up with 1 times 1 is 1. 1 times negative sign is negative sign. Then we'll have plus sign. So those will cancel. Negative sign, plus sign, and then minus sine squared. Again, this is a manipulation of one of the Pythagorean identities. 1 minus sine squared is just cosine squared. So this is going to be cosine times 1 minus sine over cosine squared. Now, this cosine and one of these cosines will cancel. So I'm going to be left with tangent of x plus 1 minus sine over cosine. Now I'm going to employ another strategy and split this up into two different fractions. Remember, we said we usually only want to do that when we have just one term in the denominator. Okay, now make sure that you understand I could not split this original fraction up into cosine plus cosine over sine, right? That is not something that is mathematically correct. But I can split this up with just that one term in the denominator. Okay, if you're interested, I could show you exactly why that is true. Okay, but you'll probably just take my word for it. So we've got 1 over cosine minus sine over cosine. Well, sine over cosine is just tangent, right? And 1 over cosine we know is secant. So I can rewrite this now as tangent plus secant minus tangent. Well, tangent minus tangent, those will cancel, and I'll just be left with secant, okay? So some of these problems will require you to use multiple of these strategies, okay? And I'm not going to tell you which strategies to use. So you're going to have to just try something, all right? I'll be more than happy to give you a hint, point you in the right direction, all right? So just ask. That is it for this video. The final question is going to pop up asking you what questions you have.